Every story has an ending. Books end, songs end, even lives end. But what if the greatest story of all, the story of the universe itself, ends not in a blaze of glory, but in silence, in fire, or in something stranger than imagination can ever hold? This is not just a question about stars or galaxies or physics. It is a question that sits quietly inside of us, whispering to our sense of wonder, unsettling our deepest assumptions about permanence, and daring us to confront the possibility that even infinity might be fragile. When most people look at the night sky, what they see is beauty, mystery, and timelessness. It feels endless. The stars seem fixed, eternal, suspended above us, like tiny holes poked into a velvet curtain, revealing a light that has always been there and will always remain. We grow up under this sky, and somewhere deep inside, we assume that the cosmos itself is immune to the same fate that awaits us, that perhaps the universe, unlike human lives or human civilizations, is permanent. Yet the truth is both humbling and astonishing. The universe, vast and seemingly timeless, may not be immune to endings at all. This matters profoundly because the very idea unsettles the natural comfort we take in permanence. To think that the universe itself may come to an end is to feel the ground shift beneath our feet. It challenges the notion that there is always a stage upon which life can play out, always a backdrop against which stories can be told. It asks us to imagine not just the death of stars or galaxies, but the death of everything, space, time, and the very laws of nature. That is the kind of thought that bends the mind, the kind that forces us to confront scales of reality so vast they defy ordinary imagination. To picture this more clearly, imagine yourself standing at the edge of an endless ocean. The water stretches out in every direction, disappearing into a horizon that seems to have no boundary. Each wave rises and falls, carrying with it the rhythm of eternity. That is how we often think of the universe: infinite, perpetual, immune to change. But even oceans are not eternal. They can evaporate under a relentless sun. They can freeze under an age of cold. They can drain away into dry basins, leaving only cracked earth behind. So too might the universe, however vast, face its own versions of evaporation, freezing, or collapse. The waves of the cosmic ocean may one day fall silent. This is more than scientific curiosity. It is a deeply human question, one that blends science and philosophy into a single meditation. If the universe ends, then so too does every story contained within it. The stories of stars that burned and died, of planets that formed and shattered, of civilizations that rose to wonder at the sky. And yet there is also an intimacy to this question, because when we ask what happens to the universe, we are also asking what happens to us. Where do we as fragile beings fit into that last chapter? Are we a passing footnote, swallowed by cosmic silence? Or do we somehow live on through memory, through meaning, or perhaps even through cycles of rebirth that science only faintly hints at? Pause for a moment and let that sink in. You are alive now, breathing in this fragile moment, listening to these words. The stars you can see in the night sky are not only light, but time itself, echoes traveling across unimaginable distances to reach you. To imagine that one day such light will fade, not just from your eyes, but from the cosmos entirely, is to brush against a kind of quiet terror. And yet it is also strangely calming, because it reminds us that we belong to something larger, a story that is far bigger than our own. Think again of that cosmic ocean. Each wave is a star, each current a galaxy. The waters appear endless, yet if you linger, you can almost sense that the ocean is slowly changing, always in motion towards something. To realize this is to step through a doorway, a threshold into a deeper understanding of the cosmos. On one side of the doorway is the comforting illusion of eternity. On the other is the unsettling recognition that even the infinite may one day end. This doorway is the beginning of our journey. It is not meant to frighten, but to awaken, to draw you closer to the mystery rather than push you away. When you walk through it, you begin to see the universe not as a static backdrop, but as a living, changing entity with a history and a destiny. You begin to see that the universe has a past, a present, and a future, just like you. And like you, it has an ending, though perhaps not in the way you expect. The most profound part of this realization is not the cold mechanics of physics or the equations of cosmology, but the way it connects us to something universal, the awareness of mortality. Humans have always told stories about endings, about apocalypses and rebirths, about the collapse of worlds and the dawn of new ones. The idea that the universe itself has an ending ties the greatest human myths to the greatest scientific discoveries, binding imagination and observation into one continuous thread. And so we arrive at a question that is as mysterious as it is unavoidable. If every story has an ending, what ending awaits the universe? Will it be a slow fading into darkness, a collapse back into fire, or something so strange that no human mind can truly capture it? These are not idle speculations. They are the deepest questions of science and philosophy, questions that reach into the heart of existence itself. But before we can understand how the story might end, we must first understand how it began. Endings, after all, do not exist in isolation. They grow out of beginnings, shaped by the same forces that set everything in motion. And so, to glimpse the universe's final chapter, we must first turn back to its opening line, the moment when everything began. Every ending is tied to its beginning. Just as the last page of a book carries the echoes of its first sentence, so too does the universe's final chapter depend on how it all began. To ask how the cosmos might end is to listen, carefully and patiently, to the resonance of its birth. That birth is not just a historical curiosity, not just a dusty fact stored in the archives of astrophysics. It is the foundation upon which every possible future rests. The great opening act of the most expansive story ever told. When we speak of the beginning, we speak of something both familiar and incomprehensible. Familiar because we have all heard the phrase, the Big Bang. Incomprehensible because what those two simple words point to stretches human thought to its limits. The Big Bang is not an explosion in space as fireworks explode in the night sky. It is the sudden stretching of space itself, the emergence of time itself, the birth of all energy, matter, and motion from a singular, incomprehensible point. Imagine a balloon, tightly crumpled, suddenly inflating. Not only does its surface expand, but with it comes the very space in which expansion is measured. The Big Bang is like that, only not on the scale of rubber and air, but on the scale of existence itself. We are accustomed to thinking of beginnings as small, quiet, tentative things. A seed sprouting, a child's first steps, a sunrise peeking above the horizon. But the universe's beginning was vast, overwhelming, blazing with unimaginable heat and density. In the first second, forces that still rule the cosmos today, gravity, electromagnetism, nuclear energy, sprang into being and set their laws into motion. In less than a heartbeat, the universe expanded faster than light, ballooning from something smaller than a speck of dust to something that contained the seeds of all galaxies yet to come. This is not exaggeration, but a humbling attempt to describe what physics, with its equations and observations, has revealed. And yet, the Big Bang was not silent. It left behind a whisper, a faint glow that still fills the universe like a ghost of its first light. This is the cosmic microwave background, the afterglow of creation, a nearly uniform wash of radiation spread across all of space. Scientists discovered it in 1965 by accident, when two radio engineers picked up a mysterious hiss on their antenna. They thought it was pigeons nesting in the equipment, but it was not pigeons. It was the echo of the beginning, the oldest light we can see, still shining softly after more than 13 billion years. That faint glow is proof that the universe did indeed have a fiery birth, and it tells us that what happens at the end will always be tied to what happened at the start. Why does this matter for the question of endings? Because the way the universe began determines the shape of its destiny. If the Big Bang sent the cosmos expanding outward, does that expansion continue forever, thinning and cooling until only silence remains? Or does the energy that launched the universe eventually reverse its course, pulling everything back together in a final collapse? To understand endings, we must stare into the nature of beginnings, because within that first explosion of possibility lies the seed of every outcome. Imagine for a moment watching the universe in reverse, like rewinding an ancient film reel. Galaxies that are now far apart would drift closer and closer, eventually merging into a single radiant mass of energy. Time itself would contract, running back to a point where physics as we know it breaks down. What lies on the other side of that point? If there even is an other side, is a mystery that may never be solved. And yet the mere act of imagining this reversal reveals how closely tied the beginning and the end truly are. The Big Bang forces us to confront paradoxes that both fascinate and unsettle. How can something arise from nothing? How can time begin if there is no before in which to set that beginning? Scientists admit that the equations bend and falter at this boundary. Philosophers have wrestled with the same questions for millennia, often turning to myths of creation that echo, in their own symbolic ways, the story science now tells. Perhaps the Big Bang is less a final answer and more a reminder that some questions are meant to stretch the human mind without breaking it. Take a moment to reflect on this. Every atom in your body, every element in your bones and blood was born from that initial furnace. The carbon that shapes life, the iron that strengthens your blood, the oxygen you breathe, all trace their ancestry back to that primal moment. You are not merely in the universe, you are of it, a direct descendant of the Big Bang. To ask how the universe will end is, in a way, to ask how you yourself will end, because the two are inseparably bound. Now consider the possibility that the same energy which birthed the universe might one day pull it back together. This is not fantasy, but a scientific possibility known as the Big Crunch, where the expansion slows, halts, and reverses. If so, the story of the cosmos may be cyclical, a beginning that leads to an ending, which in turn becomes another beginning. It is a rhythm that mirrors so many natural cycles we already know: the tides, the seasons, the rise and fall of civilizations. Could the universe itself follow such a pattern, endlessly expanding and collapsing, forever rewriting its story in new chapters? Or perhaps not. Perhaps the expansion, once set in motion, will never be undone. In this scenario, the universe stretches thinner and thinner, its galaxies drifting farther apart until no light from one can ever reach another. It is a universe destined for loneliness, an ending not of collapse but of endless dispersal. Both fates are written in the same beginning, like two paths branching from a single trailhead, and we walk along them without yet knowing which direction lies ahead. The Big Bang is, in this way, both an answer and a question. It answers the mystery of how something could come from a single origin, yet it raises even deeper mysteries about why it happened at all. If the end is tied to the beginning, then we are left with a haunting possibility. The end may be as unimaginable as the start. It may be stranger, quieter, or more mysterious than any equation can predict. And here we encounter the bridge that carries us to the next part of our journey. Expansion is the key. The Big Bang set it in motion, the balloon of space forever stretching, galaxies riding upon it like passengers on an invisible tide. But what if expansion does not behave as we once thought? What if, instead of slowing under the pull of gravity, it accelerates, speeding up as if driven by some unseen hand? That is where the story begins to twist in unexpected ways, and where the question of endings becomes even more profound. The first whispers of discovery often arrive quietly, without fanfare, and yet they reshape everything we thought we knew. In the early decades of the 20th century, astronomers peered into the night sky, expecting to find a universe that was steady and unchanging, a vast stage where galaxies remained fixed in their grand arrangement. The cosmos was thought to be eternal and static, as though it had always existed in its current form. But then came the shock. A revelation so profound that it cracked open the very framework of human understanding. The galaxies were not sitting still. They were racing away. This discovery did not come from speculation or philosophy, but from patient observation. Edwin Hubble, gazing through the great telescopes of his time, measured the light of distant galaxies. What he found was astonishing. The light was stretched, shifted toward the red end of the spectrum. This redshift was the telltale sign of motion, proof that those galaxies were retreating from us, not creeping at random, but streaming outward in all directions. It was as if the entire universe were breathing, expanding with each passing moment. To grasp this, imagine a simple loaf of bread rising in the oven. Dotted throughout the dough are raisins, each one representing a galaxy. As the dough expands, the raisins move farther apart. Importantly, none of the raisins are propelling themselves outward. They are carried by the dough itself, which stretches the space between them. In just the same way, galaxies do not necessarily fly through space. Instead, space itself expands, carrying them apart like passengers on an invisible tide. This image, humble and domestic, captures the grandeur of the universe in motion. What this means is as staggering as it is humbling. We live in a universe that is not static but dynamic, one that changes on the largest scales imaginable. The night sky may appear eternal to our eyes, but it is in truth a cosmic dance of separation, galaxies drifting apart with silent determination. Over billions of years, the distances between them grow ever larger, until the structure of the universe itself is altered. Expansion is not an event in the past. It is a process unfolding in this very moment, right now, as you listen to these words. Pause for a moment and let that sink in. Every star you have ever seen, every galaxy photographed in deep space surveys is part of this quiet motion. The universe is not still, it is stretching. Even as you breathe, the galaxies slip farther from one another, their light reaching us across increasing gulfs of space. To think of this is to feel a gentle vertigo, as though the ground beneath reality itself is always shifting. The implications of expansion are immense. For one, it transforms our understanding of time and history. If galaxies are receding now, then they must have been closer together in the past. Rewind the cosmic film far enough, and they converge into a single dense origin, the Big Bang itself. Expansion is not just a feature of the present, it is evidence of the beginning. And just as it connects us to the past, it also extends forward into the future. If galaxies continue to drift apart, then the night sky of tomorrow will not be the same as the night sky of today. Future civilizations, peering upward, may not see the same abundance of galaxies. Many will vanish beyond the horizon of visibility, their light stretched so far and thin that it no longer reaches us. This leads us to a haunting thought. The end of the universe may not arrive with fire or catastrophe, but with something quieter, lonelier. Expansion itself may be the architect of silence. As galaxies recede, stars burn out, and light fades, the cosmos might slip gradually into emptiness. Imagine a night sky with fewer and fewer stars until the heavens grow dim, until the universe is nothing but a sparse scattering of cold remnants adrift in darkness. This is not the sudden drama of collapse, but the slow unraveling of connection, a story written not in explosions, but in separation. It is a strangely melancholy vision, the thought that endings could come not through destruction, but through distance. Separation is its own kind of death, and on the largest scales, it may be the one awaiting the universe. Yet there is beauty in this idea, too. Expansion speaks of motion, of change, of a cosmos that is alive in ways both vast and delicate. It reminds us that nothing is fixed, not even the stars, and that permanence may be the greatest illusion of all. And so, we stand at the edge of a paradox. Expansion reveals a universe that is endlessly unfolding, yet it also points toward an ending where the unfolding strips away all warmth and intimacy. A story that begins with creation and abundance may close with silence and emptiness. This realization is sobering, but it is also profoundly human. For do we not, in our own lives, experience the same pattern? Beginnings rich with promise, growth and flourishing, followed by the slow dispersal of energy, the quiet of decline. The universe, it seems, carries our story within its own. But there is a question that lingers like a shadow, one that deepens the mystery. If galaxies are carried apart by expansion, should not gravity, the force that binds stars into galaxies and holds planets in their orbits, slow that expansion over time? After all, gravity is a universal embrace, pulling matter together across space. Should it not gradually tug the cosmos back toward itself, slowing the outward rush, perhaps even reversing it? That is what scientists expected once they saw the universe was expanding. Expansion, they thought, would eventually decelerate under gravity's grip. Yet reality proved stranger than expectation. Careful measurements revealed that expansion is not slowing down at all. It is speeding up, racing faster with every passing moment, as though some invisible hand were pushing galaxies apart with greater and greater force. This discovery was as shocking as the first realization of expansion itself, and it opened a new chapter in our understanding of the cosmos, a chapter filled with mystery and questions still unanswered. And so, as we drift further into this cosmic story, we find ourselves facing a new puzzle. Expansion alone is astonishing, but accelerated expansion defies comprehension. What is the source of this invisible force, this phantom energy that propels the galaxies into faster and faster retreat? It is here that science names a shadow, something unseen and unmeasured directly, yet unmistakably real in its effects. But before we name it, pause again. Imagine the universe as dough rising, not steadily, but ever more rapidly, as though heated by some unknown fire. The raisins, once drifting apart at a gentle pace, now race away from one another, leaving the loaf to expand without limit. What strange hand stokes this hidden fire? What unseen agent urges the universe into ever-accelerating flight? The answer, or at least the placeholder for one, is what we call dark energy. And in following its trail, we begin to glimpse even stranger endings for the universe. Endings more violent, more mysterious, and perhaps more profound than we could have imagined. The universe, it seems, does not like to play by our expectations. First, it surprised us with its expansion, galaxies racing outward as though the cosmos itself were alive with breath. But then came an even stranger revelation, one that left astronomers and physicists staring at their data with a kind of disbelief. Expansion was not slowing down. It was not drifting toward a graceful pause. It was accelerating, as though an invisible hand were pushing the galaxies apart, faster and faster, with every passing moment. This invisible hand has a name, though the name tells us almost nothing. We call it dark energy. The word dark does not mean evil or sinister, but rather unknown, hidden, mysterious. And energy, in this case, is more a placeholder than a true explanation. It is the word we give to a force we cannot see or measure directly, but whose effects ripple across the entire cosmos. Dark energy is not like stars or planets, things we can observe with telescopes. It is not even like dark matter, the unseen glue that holds galaxies together. Dark energy is something stranger, something woven into the very fabric of space itself. To imagine what dark energy does, think of gravity, the oldest and most familiar of cosmic forces. Gravity pulls. It gathers stars into galaxies, planets into orbits, apples toward the ground. It is the great attractor, the quiet architect of structure and shape. Dark energy does the opposite. Instead of pulling, it pushes. Instead of binding, it loosens. Where gravity seeks to weave together, dark energy drives apart. In this way, it is gravity's shadow, its counterpart, an opposing current in the cosmic sea. Pause for a moment and imagine yourself floating in that sea. Around you drift countless islands of stars, galaxies adrift on an invisible tide. At first, they move gently, their separation slow, like leaves drifting apart on a pond, but then the tide quickens. The leaves slide away faster, the water itself stretching between them. You reach out, but the space between grows too wide, too fast for contact to remain. That is what dark energy does, and it does so everywhere, always, silently, without resistance. The discovery of dark energy was like a second awakening, a reminder that the universe is not only stranger than we imagine, but stranger than we can imagine. Nearly 70% of the cosmos, by current estimates, is made of this unseen force. Think of that. More than 2/3 of everything is something we cannot see, cannot touch, cannot even properly define. All the stars, galaxies, planets, and people, the luminous matter that fills our telescopes and imaginations, make up only a small fraction. The rest is darkness, not emptiness, but an invisible presence shaping the destiny of everything. And here lies the haunting connection to our question. If dark energy is the force that drives expansion, then it will also be the force that writes the ending of the universe. What kind of ending depends on its nature, and this is where uncertainty deepens into mystery. If dark energy remains constant, steady as it is now, then the universe may drift endlessly into a future of cold stillness. Galaxies will slip further and further away until none can see one another. Stars will fade, black holes will evaporate, and the universe will dissolve into a thin mist of particles and radiation, a quiet graveyard stretched thin across eternity. This is the vision known as heat death, an ending defined not by violence but by silence, not by collapse, but by endless dispersal. But what if dark energy is not constant? What if it grows stronger with time? In that case, the expansion will not merely carry galaxies apart, it will tear them apart. First, the clusters of galaxies would scatter. Then, individual galaxies themselves would unravel, their stars flung into isolation. If the force continues to strengthen, it could overwhelm even the bonds of solar systems, wrenching planets from their orbits, tearing moons from their paths. Push further still, and even atoms might not survive, their particles ripped apart by the relentless expansion of space itself. This apocalyptic scenario is called the Big Rip, and though it sounds like science fiction, it is one of the real possibilities written into the mathematics of cosmology. Reflect on this contrast. One ending is soft, quiet, and slow, a fading into stillness. The other is violent and abrupt, a cosmic unmaking where even matter itself is undone. Both emerge from the same mystery. Both are shaped by the hand of dark energy. Which one awaits us depends on a question we do not yet know how to answer. Is dark energy constant, or is it changing? Is it steady as the ticking of a clock, or restless, growing stronger in ways we cannot yet see? Philosophically, this is almost unbearable to contemplate. We live in a universe where the majority of its substance is unknown, where the fate of everything, every star, every world, every moment of life is bound to a force we can only infer through its effects. It is like standing in a room where the air itself is alive, invisible and powerful, shaping the walls, dictating the ceiling, whispering the end of the story while refusing to reveal its own face. And yet, there is a strange beauty in this mystery. The presence of dark energy humbles us, reminding us that even with our telescopes and equations, we are still children gazing upward, still learning to read the vast book of existence. It invites us to wonder, not only about the mechanics of endings, but about the meaning of endings themselves. If the universe is governed by forces we cannot fully see or understand, perhaps our place within it is not to conquer or to know with final certainty, but to marvel, to question, and to live fully in the fragile present that is given to us. Take a breath here and let the weight of it settle. Dark energy is not a distant abstraction. It is acting upon you now. The space between every object in the universe, between you and the nearest star, between your galaxy and the next, is stretching with each moment. You do not feel it because the expansion is imperceptible on human scales. But on cosmic scales, it is everything. You are living inside a universe in motion, carried along on a current that has no shore. So where does this leave us? We have uncovered the invisible hand that pushes galaxies apart, the phantom force that may dictate how all things end. But knowledge of dark energy does not bring closure. It opens a branching path, one direction leading to silence, another to destruction. It paints possibilities, not certainties, leaving us suspended between awe and unease. And so our journey turns to follow these paths. Let us walk them carefully, one by one, beginning not with fire or chaos, but with the quietest and coldest of endings. For sometimes, the most haunting vision is not one of violence, but of silence stretched across eternity. When we think of endings, our minds often leap to images of fire, collapse, or sudden destruction. We imagine explosions, infernos, or violent shocks that bring everything to a halt in one final moment. But the universe, in its quiet indifference, may not choose a dramatic ending at all. It may instead choose something slower, softer, and far more haunting. An ending not with fire, but with the gentle fading of light. An ending called the heat death. At first, the phrase sounds misleading. How can heat be part of a death that is defined by cold? The truth lies in the language of physics, where heat is not simply warmth as we feel it, but the measure of energy in motion, the restless dance of particles. Heat death, then, is not the triumph of fire, but the exhaustion of energy itself, the moment when all useful motion has been spent, leaving behind only stillness. Imagine the universe as a great banquet lit by countless candles. In the beginning, the hall is ablaze with light and warmth, every table brightened by flames. But candles burn only for so long. One by one, they sputter and go dark. The light dims, the warmth fades, and the hall grows colder with each extinguished flame. In the end, no candle remains, no flicker of brightness, no source of renewal. Only shadows stretch across the empty room. That banquet hall is our cosmos, and those candles are the stars. The process is patient, almost unbearably slow. Stars live for billions of years, their fires sustained by the fusion of hydrogen into heavier elements. But hydrogen is not infinite. Over unimaginable timescales, stars exhaust their fuel. The brightest, most massive stars burn out quickly, exploding into supernovae, leaving behind neutron stars or black holes. The smaller, quieter stars live much longer, but even they cannot burn forever. When their fuel runs dry, they swell, collapse, and fade into cold embers called white dwarfs. And after trillions upon trillions of years, even those white dwarfs cool into black dwarfs, silent relics that no longer shine. Picture galaxies where once billions of stars blazed, slondals. First, the grand spirals lose their brilliance. Then the few remaining stars flicker out until only dead remnants drift silently. The galaxies do not vanish, but they dim, becoming cemeteries of frozen cinders and collapsed cores. Where once there was light, there is now only shadow. Yet the heat death stretches further still, beyond the lives of stars. Matter itself is not immune to decay. Protons, the building blocks of atoms, may not last forever. Some theories suggest they will eventually dissolve into radiation, leaving nothing but a thin haze of subatomic particles drifting through endless space. Even black holes, those devourers of matter and keepers of secrets, are not eternal. Over inconceivably long times, they leak away their energy as faint radiation until they too fade into nothingness. The universe becomes a place without stars, without galaxies, without atoms or black holes, a place of almost perfect emptiness. What remains is neither fiery nor dramatic. It is quiet, so quiet it is almost unbearable to imagine. A universe stripped of structure, where nothing moves with purpose, where no heat flows, where no memory of stars or life remains. Thin whispers of radiation stretch across space, too faint to warm, too diffuse to coalesce. Eternity continues, but it is an eternity without story, without change, without meaning. Pause here and think of this vision. The night sky you see today is filled with light, each star a distant candle in the darkness. Now imagine that sky drained of its brilliance until there is nothing to see, no points of light to guide your gaze, no constellations to trace. Imagine darkness so complete that the very concept of night sky no longer makes sense. The universe would not end with a bang, but with a hush, a slow extinguishing of light until there is only silence. Philosophically, the heat death is one of the most haunting possibilities. It is not the drama of collapse or the terror of destruction, but something more subtle, more existential. It is the slow erasure of everything that makes the universe vibrant, leaving behind a kind of eternal stillness. To picture it is to confront the idea that not only does life end, but even the conditions for life, the stars, the planets, the warmth of suns, fade into nothing. What meaning survives in a universe without memory, without movement, without even the possibility of renewal? Yet, in its own way, the heat death also carries a strange, melancholy beauty. It is not violent, not catastrophic. It is peaceful, inevitable, like the last notes of a symphony dissolving into silence. It is the kind of ending that allows one to imagine the universe itself drifting into sleep, laying down its energy after an endless labor of creation and change. There is sorrow in it, yes, but there is also gentleness. Some thinkers find comfort here. If the universe must end, perhaps it is better for it to end quietly, without pain, without the violence of collapse or ripping apart. Others find despair in it, because such an ending seems to strip the cosmos of drama, leaving only emptiness. Both feelings are valid, and both are mirrors of our human response to endings in our own lives. Sometimes we hope for a gentle fading. Sometimes we fear the silence more than the fire. But here lies an important reminder. The heat death is not imminent. It is not something that will happen in 1,000 years, or 1,000,000, or even 1,000,000,000. The timescales involved are so vast they defy comprehension, stretching far beyond the lifespan of stars, galaxies, or any conceivable civilization. If this is the universe's fate, it is so distant that it is almost irrelevant to us now, like a dream we can acknowledge but never inhabit. And yet, knowing of it shifts our perspective. It makes us more aware of the preciousness of the present moment, the miracle of light in the sky, the warmth of the sun, the fleeting chance to exist in a universe that is still alive with fire. Take a moment to look inward. The stars we see are not permanent, but neither are we. Our lives are brief, fragile, temporary sparks against the backdrop of cosmic time. And perhaps that is why this vision of heat death touches us so deeply, because in it we see a reflection of our own mortality. We too will fade, not with fire, but with a quiet diminishing of energy. In the end, perhaps we are not so different from the universe that contains us. And yet, endings need not always be gentle. If the heat death is one possibility, there are others, some far more dramatic. The cosmos may not choose silence after all. Instead of fading away, it may turn inward, collapsing in on itself with fiery intensity, erasing not with cold, but with unimaginable heat. So let us turn the page and follow the thread of endings once more, to a vision not of silence, but of fire. For so long, humanity believed the heavens to be fixed and eternal, an infinite stage upon which the drama of life unfolded. But with the discovery of expansion, the cosmos revealed itself as restless, alive, and dynamic. Galaxies drift apart, space itself stretches, and the fabric of the universe grows wider with every passing second. Expansion feels like the defining story of existence, an arrow pointing outward with no return. And yet, there is another possibility, one that bends this arrow back upon itself. It is the possibility of reversal, of collapse, of the universe folding inward until it ends not in silence, but in fire. This is the vision of the Big Crunch. To picture it, imagine pausing the universe's expansion, as though pressing a cosmic button that halts the outward drift. Galaxies stop receding, their momentum checked. Then, slowly, they begin to move inward, drawn together not by chance, but by the steady, unrelenting pull of gravity. At first, the change is subtle, barely perceptible across the immensity of space. But over time, the inward drift quickens. Galaxies rush toward one another, clusters collide, and the vast filaments of the cosmic web contract. The universe, once stretched wide, begins to shrink. The analogy often used is that of a ball tossed into the air. At first, it rises, carried upward by its momentum. But gravity resists. The climb slows, stops, and then reverses. The ball falls back toward the ground, accelerating as it goes. The Big Crunch is the universe as that ball, rising in expansion, then falling back into itself under the weight of its own gravity. Only in this case, the ball is everything. Every star, every planet, every particle of matter and energy rushing back toward a final convergence. As the contraction continues, the universe heats. Colliding galaxies ignite storms of star formation. The background radiation, once stretched thin and cooled by expansion, begins to warm again. The cosmos becomes denser, hotter, more chaotic. Imagine night skies blazing with the light of countless collisions, galaxies shredded and consumed by one another, stars set aflame in furious births and deaths. The shrinking universe is not a quiet place. It is a furnace, roaring louder with every passing age. At last, the contraction becomes absolute. Galaxies, stars, and matter itself are pulled closer, faster, until there is no room for separation. Everything collapses into a single fiery point, a mirror image of the Big Bang. In this final moment, the universe becomes impossibly hot, impossibly dense, all of creation compressed into an almost dimensionless speck. This is the Big Crunch, an ending of unimaginable violence, where the arrow of time itself seems to point back toward its beginning. And here lies the tantalizing possibility. If the universe ends in a crunch, could that collapse also mark the birth of a new bang? Could the death of one universe ignite the beginning of another in an endless cycle of creation and destruction? Some theories suggest exactly this, a cyclical cosmos where expansion and contraction follow one another like the beating of a cosmic heart. Each Big Bang gives rise to stars, galaxies, and life. Each Big Crunch draws them back, erases the slate, and prepares the way for something new. There is a strange comfort in this vision. It rescues us from the finality of endings, replacing them with continuity, rhythm, renewal. The universe does not die forever, but rather transforms, rebirth following death in an infinite loop. It feels almost mythic, echoing ancient philosophies that imagined time as a circle rather than a line. Civilizations from the Stoics of Greece to Hindu cosmology spoke of worlds that burn and worlds that rise again, of universes that collapse only to be reborn. The Big Crunch gives a scientific voice to this ancient dream. But there is also unease here. If cycles are real, does each new universe remember the last? Or are they clean slates without memory, without continuity? If everything we know is erased in a crunch, and if the next universe has no knowledge of this one, is that truly rebirth or simply replacement? The thought is humbling. All our stories, all our triumphs, all our griefs could vanish without trace, swallowed by fire, never to echo again. The cycle may be infinite, but we within it may be forgotten each time. Another tension lies in the very mechanics of the crunch. For contraction to occur, gravity must overcome expansion. But what if the mysterious push of dark energy is too strong? What if expansion is not only real but unstoppable, growing faster with time? Then the Big Crunch may remain forever in the realm of speculation, a possibility denied by the very laws of the cosmos. The irony is sharp. The universe may contain the seeds of its own collapse, yet also hold the power to prevent it. We do not yet know which is stronger, the pull of gravity or the phantom hand of dark energy. Still, the image of the crunch lingers in the imagination. There is something hauntingly symmetrical about it, something poetic. A universe that begins with fire and ends with fire, one that writes its story in arcs of flame rather than whispers of silence. It offers both fear and comfort. Fear, because the end is violent and absolute. Comfort, because the end may not be the end at all, but the beginning of another chapter in an endless book. Take a moment and picture this final moment. Space shrinking, galaxies rushing inward, light itself compressed until it blazes brighter than we can fathom. Time accelerates, the past collapsing into the present, the future rushing to meet it. Then everything, all at once, converges into a single luminous instant. To witness such a moment would be to see the universe fold its wings, to watch it inhale after an eternity of exhalation, to stand at the threshold of both death and birth. And yet, cycles are not the only way to imagine endings. The universe may not choose silence, and it may not choose collapse and rebirth. There are visions more chaotic still. Endings where the fabric of space does not fold inward, but instead tears itself apart. If the crunch is the universe falling back into a single fiery heart, then the next possibility is something else entirely. The undoing of space, the unraveling of everything. Let us turn to that darker possibility and ask, what if the end is not a circle, but a fracture? Of all the stories we tell about the universe's end, perhaps none is as catastrophic, as unsettling, or as awe-inspiring as the vision called the Big Rip. It is the most violent ending of all, a scenario in which not even the smallest building blocks of existence survive. If the heat death is the universe fading gently into silence, and the Big Crunch is its fiery collapse into rebirth, then the Big Rip is something different altogether. It is the unmaking of the cosmos, thread by thread, until not even matter remains whole. To understand the Rip, we must return to the phantom force of dark energy. Already it stretches the universe apart, accelerating the recession of galaxies, driving space itself to expand. For now, that expansion is steady, almost patient, a tide that carries worlds apart. But what if dark energy is not constant? What if its strength grows with time, a force that not only resists gravity, but overwhelms it completely? In that case, the future does not hold quiet separation or graceful collapse. It holds destruction, accelerating faster and faster until all bonds, great and small, are broken. Picture it first on the grandest scales. Galaxies that now drift apart will, in this scenario, be wrenched away at terrifying speeds. Clusters will scatter, their webs torn. Entire galaxies, which gravity has held together for billions of years, will no longer be safe. Stars will no longer orbit their galactic centers, because the expansion of space itself will stretch them outward faster than gravity can pull them back in. The great spirals and ellipticals, those island universes of countless suns, will dissolve into lonely fragments racing into the void. But the Rip does not stop there. As dark energy grows in strength, it moves to smaller scales. Star systems unravel. Planets slip free of their stars. Moons escape their planets. The delicate clockwork of orbits, which has governed the heavens for eons, shatters under the strain. Worlds wander into the cold, no longer tethered to warmth or light. Then the tearing reaches even further inward. Stars themselves, once bound by the titanic forces of gravity and nuclear fusion, are ripped apart. Their cores shred, their plasma scattered, their very identities lost to the accelerating expansion. Even black holes, the densest and most stubborn objects in existence, may not survive. Space expands so violently that even horizons, those final boundaries from which nothing escapes, unravel and vanish. The most permanent objects we know are undone, and then comes the final act, the most haunting vision of all. The Rip reaches atoms. The bonds that hold protons and electrons together are severed. The nucleus itself, with its fragile balance of forces, cannot withstand the expansion. Matter dissolves into a sea of quarks and leptons, fundamental particles that themselves may not endure. At this point, space itself may tear into something unrecognizable, an existence so alien we have no words to describe it. The universe does not simply end, it unravels. Pause and take a breath here and feel the weight of this possibility. The Big Rip is terrifying because it denies stability at every level. Nothing is spared, from galaxies to stars to planets to the very atoms that compose you. It is as if the universe is a tapestry woven across billions of years, and dark energy grows into the hand that pulls the threads loose one after another until there is no fabric left. And yet, there is a strange beauty in this vision as well. The rip is not random chaos. It is an ending with a rhythm, a sequence of undoing. First galaxies, then stars, then planets, then atoms. It is the ultimate expression of impermanence, a cosmic reminder that nothing, not even the most fundamental bonds, last forever. To imagine it is to stand in awe of both the fragility and the grandeur of existence. The implications stretch beyond science into philosophy. If the universe ends in silence, we might still imagine its memory carried on in faint radiation. If it ends in collapse, we might imagine rebirth. But if it ends in a rip, what remains? If even the smallest particles are undone, there may be no continuity, no echo, no after. It is an ending more absolute than death because it leaves behind no remains, only the absence of remains. The thought unsettles us because it challenges the very notion of persistence, the comforting belief that something, however small, endures. There is also a deeper unease here. The Big Rip is not only a scientific possibility, but also a metaphor for fragility in all things. Just as stars and galaxies might someday lose their bonds, so too do we live lives where bonds break, where time stretches us apart from what we love, where everything we build is vulnerable to unraveling. The cosmic and the human mirror each other, and in that mirror, we glimpse both terror and tenderness. Scientists, of course, caution us that the Big Rip remains speculative. We do not yet know whether dark energy changes with time. It may be constant, in which case the rip never comes. Or it may evolve, gently or violently, shifting the destiny of the cosmos in ways we can scarcely imagine. What matters is that our current understanding admits the possibility, and in that possibility, we find both fear and wonder. Take another breath and let this image linger for a moment longer. A universe tearing apart at every seam, dissolving not into silence or fire, but into absence. It is the most catastrophic story we can tell, one that leaves us grasping for meaning in a cosmos that might one day be entirely unmade. And yet, even as we tell it, we are alive in a universe still full of stars, still bound together, still whole. Perhaps that is the deepest lesson of the Big Rip, that we should cherish the bonds while they last, because even the universe does not promise permanence. And so, our journey moves forward. We have walked through silence, collapse, and unmaking. We have seen endings that roar and endings that hush. But not every vision of the universe's fate is violent. Some speak instead in whispers of slow dissolving and subtle change, of endings that feel more like dreams than catastrophes. Let us turn to one of these quieter possibilities and listen for what it has to say. The universe is vast beyond comprehension, but it is also restless. From the first moments of the Big Bang until now, it has stretched outward, carrying galaxies along like leaves on a flowing river. We have imagined endings where this river turns violent, tearing everything apart, and endings where it flows back into itself, collapsing in fire. But what if neither happens? What if the universe simply continues as it is, expanding forever, yet never destroying, never collapsing, never quite reaching catastrophe? This vision is not one of fire or silence, but of slow and endless drifting, a future sometimes called eternal expansion. To imagine it, think of galaxies as lanterns scattered across a dark field. At first, they are close enough to see one another, their glow forming patterns and constellations in the night. But as time passes, the lanterns drift apart. The farther they move, the fainter they seem, until at last each lantern shines alone, no longer part of a larger picture, no longer connected to any other. This is what eternal expansion does. It leaves behind not destruction, but isolation. On the largest scales, this process is already underway. The galaxies outside our local group, the small family that includes the Milky Way and Andromeda, are receding at speeds so great that one day their light will never reach us again. Each year that passes, more galaxies slip beyond our cosmic horizon. To future observers, if such beings exist, the universe will not appear as the vast sea of galaxies we see today. Instead, they will look up and see only their own galaxy, floating in darkness. Imagine being part of such a civilization, countless billions of years from now. They gaze at their night sky, and it tells them a different story. They see stars, yes, but no galaxies, no great spirals beyond their own, no grand clusters spread across the void. The sky appears smaller, lonelier, more confined. They may not even know that a wider universe ever existed. Without galaxies to hint at expansion, without the glow of the cosmic background radiation, which itself will fade into undetectability, they may live in a cosmos that feels static, eternal, and solitary. To them, the story of the universe as we know it, the Big Bang, the expansion, the great tapestry of galaxies, may be unknowable, lost forever beyond the horizon of sight. And so eternal expansion creates a paradox. The universe itself continues, stretching endlessly, but those within it may never sense the vastness. The cosmos grows wider, but the perspective of its inhabitants grows narrower, until their visible universe is only a tiny bubble, a small island adrift in a sea that cannot be seen. The grand shared cosmos dissolves into countless isolated pockets, each believing itself alone. The emotional weight of this vision is subtle but heavy. It is not the terror of being torn apart, nor the violence of collapse, but the ache of loneliness. The universe does not die. It simply drifts apart until no connection remains. In this way, eternal expansion is not a destruction of matter, but of relationship. It dissolves the bonds that make the cosmos feel whole. Galaxies lose one another, civilizations lose the ability to glimpse beyond themselves, and the universe becomes a scattering of isolated islands, each with no knowledge of the others. For us, here and now, this possibility adds poignancy to our moment in history. We live in a rare cosmic age, one where the evidence of the Big Bang is still visible, where galaxies still fill the sky, where the cosmic microwave background still whispers of the beginning. We are privileged to exist in the chapter when the universe reveals itself most clearly. Future civilizations, should they rise in an age of isolation, may never know what we know. For them, the story of the cosmos may appear much smaller and perhaps far lonelier. But there is also a strange serenity in the idea of eternal expansion. Unlike the violent visions of the Rip or the Crunch, here the universe continues in peace. Stars still burn, planets still orbit, black holes still lurk in the shadows. Though galaxies drift apart, each remains intact within itself, preserving its stars and worlds. Life, if it arises in such an isolated future, may thrive for eons without fear of collapse or unraveling. For those who value continuity, eternal expansion feels less like death and more like an endless twilight, a long drifting into quiet distance. Philosophically, this possibility invites reflection on connection and separation. In our own lives, we know the ache of distance, the slow drifting of people, places, and memories beyond reach. Eternal expansion mirrors this human truth on the largest possible scale. Just as we feel the loss of connection in our own stories, the universe itself may someday dissolve into solitude, each galaxy cut off from its kin. And yet, even in solitude, life may persist. Meaning may still be made in small, isolated corners of an endless, expanding cosmos. Take a moment to imagine yourself as a being in that distant future. Your civilization has mapped the stars of your galaxy in exquisite detail. You have probed the mysteries of physics, explored countless worlds, perhaps even mastered your own sun. But when you look outward, there is nothing more. No galaxies, no clusters, no echo of beginnings. To you, the universe is small, bounded, eternal. You live in a cosmos of one. What stories would you tell? What myths would you weave about your place in existence, without ever knowing the truth of the wider whole? And yet, for us, the truth is still visible. We still stand on the shore of a cosmos filled with galaxies, each receding, but still within reach of our gaze. We still hear the faint echo of the Big Bang humming through the sky. We still know, in this fleeting age, that the universe is vast, shared, connected. And perhaps that knowledge is its own kind of gift, one that future ages will not have. Eternal expansion is not fire, not collapse, not ripping apart. It is a slow and endless drifting, a universe that grows without end, yet leaves behind loneliness in its wake. It is a cosmic exile, where every galaxy becomes a solitary island, carrying its stars into the endless night. And yet, even in that endless night, mysteries remain. For expansion may not be the only story. There are stranger and more intimate forces still at work, shaping the fate of what lies within galaxies themselves. To find them, we must turn inward, to the dark hearts of galaxies, to the enigmatic engines that swallow stars and bend the fabric of space. Let us step now into that shadow, into the mystery of black holes. Every era of the universe has its rulers. In the beginning, light itself was king, a hot flood of photons filling the cosmos with brightness. Then came the age of matter, when stars and galaxies took shape, painting the night with fire. Later, dark energy rose to prominence, dictating the grand rhythm of expansion. But if we step far enough into the future, into time so long that even the lives of stars seem brief in comparison, a new power claims dominion. It is a kingdom without light, ruled not by suns or galaxies, but by shadows. It is the reign of black holes. To enter this era is to step trillions upon trillions of years beyond our present moment. By then, the last of the stars will have burned through their fuel. The bright galaxies we know today will have dimmed into fields of dark embers, populated only by white dwarfs cooling into black dwarfs, neutron stars slowly fading, and the quiet relics of stellar life. Light, once abundant, will be rare. Energy will be scarce. And amidst this quiet graveyard, black holes will remain. Black holes are the most enduring objects in the cosmos, born in violence but persisting in silence. They form when stars many times larger than our sun collapse under their own gravity, compressing into points of such density that not even light can escape. Over time, as stars continue to die, galaxies are gradually seeded with these invisible giants. They lurk in the centers of galaxies, swallowing gas and stars, and they drift through the galactic halos, patient hunters awaiting their next meal. Imagine a future galaxy in this era, though galaxy may no longer be the right word. Most of its stars have gone dark, their embers fading into the cold. Few sources of light remain. Yet black holes persist, slowly devouring what is left. A lone star might wander too close and vanish into the event horizon, leaving behind only a flare of energy as it is torn apart. A cluster of planets, untethered from a long-dead star, might spiral inward, lost forever in the shadows. The black holes wait, and given enough time, they consume. This vision extends across the universe. Where once galaxies blazed with countless suns, the future is a place of quiet, where black holes are the main actors. They are the final sculptors of cosmic history, tidying away the remnants, gathering the fragments of matter into their invisible embrace. In this age, the night sky would be almost empty. Perhaps the faint glow of a dying star, perhaps the occasional flash of matter consumed, but mostly silence, mostly shadow. A universe of invisible giants, each one patient, each one eternal in appearance. And yet, this kingdom of black holes is not as eternal as it seems. They may feel indestructible, the final word of matter, the end point of collapse, but they are not beyond time's reach. For now, let us stay in their reign a little longer and imagine its meaning. Philosophically, the black hole era is fascinating because it reverses our sense of light and darkness. For most of cosmic history, light has been the storyteller. We see galaxies because their stars shine. We learn the universe's secrets because photons carry messages across time. But in the era of black holes, light is scarce, and darkness becomes the rule rather than the exception. The cosmos no longer tells its story through brilliance, but through silence. It is as though the stage of the universe dims, and only shadows remain as actors. On a deeper level, the reign of black holes is humbling because it reminds us of the limits of permanence. Even the most massive and luminous stars, even the grandest galaxies, give way to the quiet persistence of these collapsed remnants. In the long view of time, power does not belong to brightness but to endurance. The black holes do not shine, yet they outlast everything that does. There is a melancholy here, but also a strange kind of respect, as though the universe acknowledges their patience by granting them the longest reign. Take a moment and place yourself in that distant age. Imagine a civilization if one could exist in such a barren time. Their sky would be nearly empty. Their history books might speak of a time long past when galaxies filled the heavens, but they themselves would see almost nothing. For them, the universe would feel small, desolate, and ruled by shadows. Perhaps they would worship black holes as gods, invisible but omnipresent, powerful but unknowable. Perhaps they would fear them as the ultimate predators, capable of swallowing anything that wanders too near. Or perhaps they would simply endure, carving meaning out of the long darkness, as humans have always done. And yet, as powerful as black holes are, their reign cannot last forever. For even they are subject to a strange law of physics, one that whispers of their eventual end. Stephen Hawking revealed that black holes are not entirely black, that they leak energy in the form of faint radiation. Over timescales far longer than the current age of the universe, this Hawking radiation will cause black holes to shrink, slowly evaporating into nothingness. The largest of them may last unimaginably long, but not infinitely so. Even the kings of the cosmos will one day abdicate their thrones, leaving behind no trace of their reign. This thought reframes the story of black holes in a profound way. Their dominance, though long, is not eternal. The universe, in its quiet persistence, will eventually erode even its strongest structures. Stars may die quickly, galaxies may dissolve over eons, but black holes too are mortal. The shadows that outlast the suns will themselves fade, whispering their energy into the night until nothing remains. So what does it mean to live in a universe that erases even its most enduring monuments? Perhaps it teaches us something about impermanence, about the futility of clinging to permanence in a cosmos where nothing is truly safe from time. And yet, perhaps it also teaches us to value the fleeting more, to see beauty not in what endures forever, but in what shines brightly before fading. In the great timeline of the universe, the era of black holes is a chapter that feels both final and transitional. Final, because it marks the last great structures, the last rulers of matter. Transitional, because it leads to an even quieter age, when even they are gone, and the universe has nothing left to offer but emptiness. And so, as we leave behind the reign of these dark kings, we step into an even more haunting possibility. The era after black holes, when the universe whispers its last through the faintest traces of energy. For even shadows cannot last forever. Black holes feel eternal. They are the great anchors of galaxies, swallowing suns, bending space into funnels from which even light cannot climb. To think of them is to imagine permanence, shadows so absolute that nothing can erase them. But the universe is relentless, and even the darkest giants are not immune to time's slow erosion. Against all intuition, black holes too will fade. Their end comes not with a roar, but with a whisper, a faint glow that Stephen Hawking, in a bold stroke of imagination, first revealed to the world. The discovery was not made in the heart of space, but in the mind of a physicist. In the 1970s, Hawking began probing the strange borderlands where gravity and quantum physics overlap. Black holes were thought to be absolute traps, regions of space where nothing, not even the smallest photon, could escape. Yet when Hawking blended Einstein's theory of gravity with the restless uncertainty of quantum fields, a startling picture emerged. Space, it turns out, is never empty. Even the void seethes with tiny fluctuations, particles appearing and disappearing in pairs. Near the edge of a black hole, these ghostly partners can be torn apart, one falling in, the other escaping. From the outside, this looks as if the black hole itself is radiating. This radiation is unimaginably faint, far beyond our instrument's ability to detect today. But the implication is vast. It means black holes are not eternal. They lose energy, little by little, bleeding their mass into the cosmos. Over inconceivable timescales, they shrink. Large black holes fade more slowly, small ones more quickly. But no matter their size, given enough time, every black hole will eventually vanish. The universe's greatest predators are also its most patient victims. Picture the far future, long after stars have died and galaxies have drifted into silence. What remains are black holes, scattered across the dark. They drift like silent monarchs, each alone in a sea of emptiness. For trillions upon trillions of years, they wait. They consume what little remains, dust and wandering remnants, yet always they lose more than they gain. Hawking radiation trickles outward, a steady leak of energy that grows as the black hole shrinks. In their final moments, these giants do not fade quietly. As a black hole grows smaller, the process of evaporation accelerates. The faint trickle of radiation swells into a flood. In the last heartbeat of their existence, black holes release an enormous burst of energy, the equivalent of countless atomic bombs, perhaps even rivaling the brightness of an entire galaxy. After eons of silence, the end of a black hole is a brilliant flare, a last cosmic firework in the empty night. And then, nothing. The black hole is gone, leaving only the afterglow of radiation. No core remains, no remnant, no trace of its presence. The ultimate monument of gravity simply ceases to exist. There is something deeply poetic in this fate. Black holes, once symbols of permanence, are undone by the same laws that shape everything else. They are not eternal prisons, but temporary phenomena, like stars, like galaxies, like everything. They endure for unimaginable spans of time, but not forever. Even the universe's darkest giants must one day yield to the whisper of quantum physics. The implications stretch far beyond astronomy. Hawking radiation forces us to rethink permanence itself. For much of human history, people imagined certain things as unchanging: the Earth, the stars, the heavens. Science has revealed instead a restless universe, where nothing stands still, where even mountains crumble, stars collapse, galaxies dissolve. Black holes once seemed the last refuge of permanence, yet even they fade. If nothing endures forever, then the universe itself becomes a story of impermanence, written across epochs too vast for us to truly grasp. Take a moment to imagine being present at the death of a black hole. Perhaps your civilization has survived into this distant age, clinging to the last reservoirs of energy in a barren cosmos. You look to the sky, which has long been dark, punctuated by only a handful of dim objects. Then, suddenly, the silence breaks. A point of blinding light erupts, brighter than all else combined. For a brief span, the universe glows again, as if remembering its youth. You watch as the flare fades, leaving emptiness behind. And you realize you have witnessed not just the end of a star, not just the death of a galaxy, but the death of a black hole, the last gasp of matter itself. This image carries a strange beauty. The universe, once ablaze with countless suns, ends not with a single flame, but with many tiny sparks scattered across the void. The final moments of existence are not silence, but a series of soft hisses as black holes release their last breaths into nothingness. It is as though the cosmos sighs before falling asleep forever. For philosophy, Hawking radiation also raises haunting questions. If black holes evaporate completely, what happens to the information of what they consumed? Does it vanish too, erased from the record of the universe? Or does it survive, hidden in subtle patterns of radiation, waiting to be decoded? This information paradox remains one of the greatest puzzles of modern physics. It suggests that the death of a black hole is not only a physical process, but also a mystery of knowledge and memory. If the universe itself forgets, what does that mean for everything it once held? In the quiet rhythm of this vision, there is also a mirror for our own lives. We too are not permanent. We flare brightly for a while, then fade. Our memories, our stories, our presence in the cosmos, none are immune to time. Like black holes, we may feel immovable in the moment, yet we are part of the same current that erodes even the strongest. There is melancholy in this, yes, but also a strange kind of peace. Impermanence gives weight to the present, makes it precious, makes it real. So the kingdom of black holes, once dark and seemingly eternal, ends in light. Not in endless shadow, but in bursts of energy scattered across time. The last rulers of the universe leave behind their thrones and dissolve into whispers. Their departure marks the beginning of an even quieter epoch, one without stars, without galaxies, without black holes. A cosmos stripped of structure, emptied of form, left only with thin radiation drifting in silence. And so we step from an age of shadows into an age of near nothingness. The black holes have gone, their fireworks spent. What remains is a question so haunting it feels almost unanswerable. When even the darkest giants have faded, what is left of the universe at all? Let us walk into that silence now, into the space beyond endings, and ask, after the last black hole, after the last flare, what remains? When we picture the end of the universe, we often imagine silence, darkness, and emptiness so complete that nothing more can follow. The stars are gone, the galaxies have dissolved, even the mighty black holes have evaporated into whispers of radiation. What remains seems final, a cosmos stripped bare until only cold and stillness endure. Yet physics, especially the strange world of quantum mechanics, refuses to leave us with such certainty. For in its quiet equations lies a peculiar truth. Nothingness itself is never truly nothing. Even in emptiness, possibilities stir. quantum physics reveals that the vacuum of space is not a static void, but a restless sea. Invisible fluctuations ripple through it constantly, particles appearing and vanishing in pairs too quickly to be seen. These flickers are brief, like sparks that ignite and extinguish before a flame can catch, but they remind us that the cosmos does not tolerate stillness. On the smallest scales, reality vibrates with motion, even when it seems completely empty. If this is true, then perhaps the end of our universe is not a wall, but a doorway. Perhaps the silence after all structure dissolves is not eternal, but pregnant with potential. Out of the vacuum, new bubbles of space and time might emerge, tiny pockets that swell into new universes. To us, they would appear unreachable, cut off forever from our fading cosmos. But from within, to those who inhabit them, they would feel as vast and alive as our own. Imagine standing at the very edge of existence in that final, frozen epoch. Around you, nothing remains but thin radiation, stretched so wide across space that it barely exists at all. The sky is black, the silence complete, and then, imperceptibly, a tremor passes through the void. A bubble forms, not of matter, but of possibility. It swells, it grows, it breaks away. Inside it, space inflates, energy ignites, and a new cosmos is born. Its beginning may resemble our own Big Bang, its expansion rapid and unstoppable, its story fresh and untainted. In this way, what we call an ending may instead be a transition. The death of our universe may be the birth of another. To us, the curtain falls. To others, it rises for the first time. The silence after giants is not the final word, but the prelude to resurrection. This idea is more than poetic speculation. Some cosmologists seriously propose that universes may bud from the vacuum, each with its own physical laws, its own balance of energy and matter, its own tapestry of stars and galaxies. We may be living in just one of countless universes, each arising from quantum fluctuations, each telling its own story. If so, then the end of our universe is not unique. It is simply one chapter in an endless library, one book closing as others begin. The implications of this possibility are staggering. If universes can be born from nothing, then perhaps nothing is an illusion. What seems like the end may always contain the seed of a beginning. Permanence may not exist in forms, in stars, or in galaxies, but perhaps it exists in the cycle itself, the eternal play of beginnings and endings, each one sprouting from the silence of the last. Philosophically, this is both comforting and unsettling. Comforting because it suggests that the universe does not truly die. Unsettling because it reminds us that our universe is not special, not singular, not privileged. It is one story among many, and when it ends, others will carry on. The cosmos is bigger than we can ever imagine, not just in space, but in possibility. Take a moment to reflect on what this means for us, here and now. We live in a universe that may one day fade into silence, yet that silence itself may ignite new beginnings elsewhere. Perhaps we are connected not just to our cosmic past, the Big Bang that birthed our world, but also to countless futures, invisible to us, but seeded by the same restless quantum sea. It is humbling to think that the atoms in our bodies, forged in ancient stars, may one day dissolve into the vacuum, and from that vacuum contribute in some unknowable way to the birth of another universe. In this sense, endings and beginnings are not separate, but intertwined. And yet this vision is not without mystery. If universes can emerge from nothing, what gives rise to the laws that shape them? Why should the vacuum itself have the power to create? Is this process infinite, eternal, unbounded? Or is there some deeper principle we do not yet understand? Some cosmic root that anchors even the sea of fluctuations? Quantum resurrection offers hope, but it also teases us with unanswered questions. Still, the poetry of the idea lingers. Imagine universes blooming like flowers in a garden too vast to see, each one opening as another closes. Imagine a tree of existence, branches splitting endlessly, each bearing its own cosmos, its own stories, its own possibilities for life and meaning. We may never glimpse beyond our branch, but the knowledge that others may exist changes the way we see our own. And perhaps this is the ultimate gift of the idea. To live in a universe that will end can feel heavy, even despairing. But to live in a multiverse where endings are beginnings and silence is seed feels lighter. It suggests that existence itself is fertile, that the cosmos has no need for finality. Even when one story ends, the song continues, though in a voice we may never hear. As we linger on this thought, the rhythm of time softens. The sharp edge of death blurs into the curve of renewal. What felt like a wall now feels like a horizon, distant but promising. The universe, it seems, is not only a story of fading, but also of becoming. And yet, even as we imagine these rebirths, another puzzle rises to the surface. If the cosmos can resurrect itself endlessly, why does time always move forward? Why do beginnings feel distinct from endings? Why does the arrow of time point in only one direction, carrying us from birth to death, from creation to dissolution, never back again? This question lies at the very heart of our experience, and at the heart of the universe itself. To follow it, we must turn from space to time, from the quantum froth of possibility to the flowing river that carries us along. For perhaps the deepest mystery of all is not how the universe ends, but why it moves forward at all. In our daily lives, time feels like the most natural thing in the world. We wake, we move, we grow older. Moments flow like a river, carrying us forward whether we wish it or not. Milk spills onto the floor but never leaps back into its glass. A candle burns, its flame consuming wax, but the wax never rebuilds itself to feed the flame again. Time, it seems, has a direction. Forward. Always forward. But why should it be so? What is it in the fabric of the universe that draws us irreversibly from past to future? The answer lies in a concept both simple and endlessly profound: entropy. Entropy is the measure of disorder, the degree to which energy spreads and structures dissolve. A freshly stacked deck of cards is ordered, while one scattered across the floor is disordered. A new star is structured, dense and burning brightly, while the remnants of an exploded star are diffuse and scattered. The second law of thermodynamics tells us that in any closed system, entropy tends to increase. Structures break down, energy disperses, order fades into disorder. This relentless increase in entropy is what pulls time along. It is the silent metronome that gives the arrow of time its forward motion. The connection between entropy and time becomes clearer when we think of memory. We remember the past because it is ordered, because it left imprints on the world. Fossils in stone, photographs on paper, synapses in the brain. The future, by contrast, is still unformed, more disordered, more uncertain. The universe began, so far as we know, in a state of extraordinary order, packed tightly into a hot, dense, uniform whole. From there, entropy has only increased, giving rise to complexity, to stars and galaxies, to life and thought, even as it continues its march toward disorder. We are, in a sense, living in the wake of that increase, carried forward on entropy's tide. But entropy raises unsettling questions when we project it into the far future. If time is tied to disorder, what happens when disorder can go no further? If the universe reaches heat death, a state of maximum entropy where no more energy can flow and no more order can form, does time itself lose its meaning? In such a cosmos, nothing changes, nothing evolves, nothing happens. Time may still exist as a dimension, but without difference between one moment and the next, it may feel like no time at all. The arrow that once pulled us forward might dissolve into stillness, leaving the universe not only lifeless, but timeless. And yet, quantum possibilities complicate this vision. If new universes can bubble forth from the vacuum, as some theories suggest, then each new cosmos may begin again with low entropy, a fresh arrow of time stretching forward. In this view, entropy does not end but resets, each universe carried along by its own tide of disorder, each one beginning in order and moving toward chaos. Time, then, may not be a single arrow, but a vast forest of arrows, each one belonging to its own cosmos, each one drawing its own story from beginning to end. Philosophically, the arrow of time is both intimate and cosmic. It shapes our lives in ways so ordinary we forget to notice. We live by clocks, by calendars, by the changes in our bodies and the cycles of the world. But beneath these patterns lies the deeper truth, that everything we experience, every memory, every loss, every moment of growth, exists because the universe began in an ordered state and has been unraveling ever since. The arrow of time is not only the story of the cosmos, it is the story of us. There is also a strange melancholy in this recognition. The same law that gives us direction, that allows stories to unfold, that makes life possible, is also the law that guarantees endings. Entropy allows candles to burn, but it also ensures they will burn out. It allows stars to shine, but it also ensures they will fade. It allows us to live and remember, but it also ensures we will grow old. The arrow of time is both gift and curse, both the reason for life and the reason for death. And yet, there is beauty here too. Imagine if time had no arrow, if everything unfolded forward and backward with equal ease. Milk could leap back into the glass, candles could rebuild themselves, stars could reform after exploding. But in such a universe, memory might be meaningless, stories incoherent, life itself impossible. It is precisely because time flows one way that we can grow, that we can learn, that we can become. Entropy may seem cruel, but it is also the silent architect of existence. Take a moment to feel this paradox. On one hand, entropy drags everything into disorder. On the other, without it, we would not exist at all. The same law that ensures our endings also ensures our beginnings. Perhaps then, the arrow of time is not an enemy but a companion, a force to be understood and even embraced, for it is what makes the universe alive, dynamic, and filled with stories. Still, questions linger. If time is bound to entropy, is entropy itself absolute? Could there be deeper laws that bend or reset it, laws we do not yet understand? Some speculate that time itself may be emergent, not fundamental, a byproduct of relationships between quantum events. If so, then the arrow of time may not be universal but local, different in each bubble of existence, different in each universe. Perhaps time is not a single river, but many streams, some flowing forward, some backward, some in ways we cannot even imagine. Such possibilities are dizzying, but they also reveal the limitations of our perspective. We live in one cosmos, at one moment, in one arrow of time. From here it feels absolute. But the universe has surprised us before, and it may yet again. Perhaps when our arrow ends, another begins. Perhaps when entropy has done all it can, some deeper order stirs beneath, waiting to rise again. As we close this reflection, notice the way time feels right now. The past lies behind you, memories stacked like stones. The future lies ahead, uncertain, yet inevitable. The present slips through your fingers even as you try to hold it. This flow is the most intimate experience we have, yet also the most cosmic. The arrow of time ties our lives to the life of the universe itself. And here is where philosophy begins to take hold of science. For to ask about time is not only to ask about entropy or physics, but also about meaning, memory, and mortality. It is to ask not only why the universe moves forward, but why we do, and what that forward motion means for us. To continue, we must now step deeper into this meeting of science and philosophy. For if the cosmos ends, and if time itself may end, then what becomes of meaning, of story, of us? We have spoken of fire and silence, of collapse and expansion, of rips and rebirths. We have pictured galaxies extinguishing one by one, and black holes whispering their final radiation into a cold void. Yet there is another possibility, one that is stranger still. What if none of it is final? What if endings themselves are illusions, not truths carved into the bones of reality, but tricks of perspective, artifacts of how we perceive time and change? It is tempting to think of the universe as a grand story that unfolds from a beginning to an end, like a line stretched taut between two poles. This is the way our lives feel. We are born, we live, we die. We learn to read stories, and stories demand an ending, a conclusion that ties the threads together. But some thinkers, both in physics and philosophy, have wondered whether this structure is simply a human invention, a way of giving shape to something that has no inherent beginning or end. In physics, this idea emerges in what is called the block universe, or eternalism. In this view, time is not a river flowing forward, but a landscape laid out all at once. Past, present, and future all exist together, each moment a fixed coordinate in the geometry of space-time. We move through these moments in sequence, like a reader turning the pages of a book, but the book itself is already complete. The ending is not something waiting for us in the future. It is already there, as much a part of reality as this moment or the first instant of creation. Imagine a novel resting on a table. From our perspective as readers, the story unfolds page by page, line by line. We meet the characters, we discover their struggles, we watch them change. To us, the ending is unknown, suspenseful, waiting in the future. But to the novel itself, the ending has always existed. The final page sits alongside the first, waiting to be read. It is not potential, but actual. In the block universe, our cosmos is that novel, already written from beginning to end. This idea is unsettling because it challenges our sense of freedom and flow. If the future already exists, are we truly making choices, or are we simply playing out a script? If the end of the universe is already written, does it make sense to speak of endings at all? Perhaps what we call an ending is only a place in the structure, no different in kind from the middle or the beginning. Just as the number 10 does not erase the number 5, the end of the universe does not erase the moments that came before. They coexist, eternal, held in the fabric of space-time. The illusion of an ending may also be tied to our perception of time's arrow. Entropy tells us that order dissolves into disorder, and so we imagine a destination, a final state. But what if entropy is simply a measure of how we observe the universe, not a law etched into its foundation? From another vantage, one we cannot yet imagine, perhaps time does not move, perhaps entropy does not rise, perhaps all is already there. In such a view, the heat death of the universe is not an event in the future, but one face of the structure, coexisting with the Big Bang, with your first breath, with this very moment. Philosophically, the implications are profound. If the universe is timeless, then our lives are timeless as well. Every joy, every sorrow, every act of love or cruelty, every breath we take, all of it exists forever. It does not vanish when time moves forward, because time is not moving. The child you once were still exists, not as a memory but as a slice of reality, as real as you are now. The person you will become also exists, not as a possibility but as a fact, waiting in another corner of the structure. To speak of an end in such a universe is to misunderstand its nature. There is no ending, only different regions of existence. Of course, we cannot help but live as though endings are real. Stories matter because they end. Relationships matter because they are finite. Our lives gain urgency because time carries us forward, whether we wish it or not. If all moments already exist, then the poignancy of endings is not in their finality, but in our experience of them. To us, endings are real because we move through the universe as travelers, not as beings who see the entire map. The end may be illusory on a cosmic scale, but it is real enough for us. There is also a curious comfort in this vision. If the end of the universe is already written, then so too are all the moments we hold dear. They cannot be erased because they already are. The laughter of a child, the glow of a star, the warmth of a touch. These are not fragile sparks destined to vanish into darkness. They are coordinates in space-time, eternal, indestructible. You do not lose them any more than the final page of a novel erases the first. They remain, forever part of the structure. This is not to say the block universe is true. It is one interpretation among many, a way of making sense of the strange relationship between time, physics, and perception. But even as a possibility, it stretches the imagination. It asks us to rethink what an ending is, to see it not as annihilation, but as one feature among countless others in the grand design of reality. And perhaps this is the deeper lesson, that endings, whether of a life, a civilization, or a cosmos, are not absolute. They are perspectives, points of view. From where we stand, endings loom large. But from another vantage, beyond time, there are no endings at all. There are only patterns, shapes, and moments coexisting in a timeless whole. So when we ask, how will the universe end? We may also be asking the wrong question. Perhaps the universe does not end, because it never began in the way we think. Perhaps it simply is a timeless tapestry, a book whose pages are already bound. Our journey through it is what gives us the illusion of beginnings and endings, of past and future, of rise and fall. But behind the illusion lies something more mysterious, something we cannot yet name. And so, what if the end is not the end? What if the end is simply another page, already written, waiting to be turned? The thought leaves us suspended between physics and philosophy, between what we can measure and what we can only wonder. It is here, in this suspension, that imagination takes root. For beyond science and philosophy lies another realm, the realm of human creativity, where endings and beginnings are reshaped not by equations, but by the stories we tell. And so, from illusion, we step into imagination. When we wonder how the universe will end, we are not only gazing outward into the silent reaches of space, we are also gazing inward into the deepest corners of our own minds. To ask about the fate of the cosmos is, in some sense, to ask about ourselves. The question is not just what happens to galaxies, but what happens to us when all of this is gone. It is a mirror, one that reflects both the grandeur of the universe and the fragility of human life. Throughout history, human beings have told stories of endings. Ancient mythologies imagined apocalypses where fire consumed the world or floods erased it, only for new life to emerge afterward. Religions envisioned heavens and hells, eternal cycles of birth and death, or final judgments that bring history to a close. In modern times, science offers its own versions of these myths. The heat death, the big crunch, the big rip, eternal expansion. When we look at them closely, these scientific fates are not so different from the stories our ancestors told. They are reflections, cosmic metaphors woven from human experience. Consider the idea of collapse. In human life, we fear collapse. The fall of civilizations, the breakdown of the body, the crumbling of everything we have built. The Big Crunch echoes this fear, a universe folding in upon itself, everything rushing back to the fiery point from which it began. Yet collapse also carries the possibility of rebirth. A fallen tree feeds the soil. A collapsed star becomes a black hole or a nebula that seeds new stars. The myth of cosmic collapse mirrors the human intuition that endings might contain beginnings, that death might be followed by renewal. Now think of fading. We know what it is to watch light dim, to see people we love slip quietly into memory. The heat death of the universe echoes this, a cosmos not consumed by fire, but by silence as stars wink out one by one and warmth drains into the void. It is the image of an old age stretched into eternity, a fading heartbeat that slows and slows until it is no more. This vision resonates with our quietest fears, the fear not of pain but of emptiness, of a silence so complete it erases even memory. And then there is unraveling. To watch something unravel is to see it come apart thread by thread until there is nothing left to hold together. The Big Rip embodies this fate, a universe undone by its own expansion, galaxies, stars, planets, even atoms torn apart by the relentless stretching of space. It is the nightmare of dissolution, the terror that even the most fundamental bonds cannot endure. Yet it also speaks to awe, to the astonishing thought that space itself could unmake its own creation. But not every story of endings is violent. Some endings are gentle, marked not by destruction, but by distance. Eternal expansion paints such a picture, galaxies drifting so far apart that each becomes an island alone in the dark sea of space. It is loneliness on the grandest scale, an echo of human loneliness, when we drift away from one another, when distance grows until voices can no longer be heard. The universe, in this story, does not collapse or unravel, it simply drifts into solitude, a fate that resonates with the human heart as deeply as fire or silence. Seen in this way, the fates of the universe are not just scientific hypotheses, they are mirrors of the human condition, projections of our fears and our hopes, shaped by the patterns of our own lives. Collapse reflects our awareness of mortality and the possibility of renewal. Fading reflects our sense of fragility and the finality of loss. Unraveling reflects our fear of dissolution, of being torn apart by forces we cannot control. Isolation reflects our longing for connection and our dread of being left alone. Perhaps this is why the question of the universe's end feels so haunting. We are not simply asking how matter behaves on the largest scales. We are asking about meaning, about whether our own stories matter if everything vanishes. To wonder about the fate of the cosmos is to wonder about our place within it. Are we fleeting sparks in an indifferent void? Are we participants in an eternal cycle of birth and rebirth? Are we chapters in a book already written, or are we co-authors shaping the ending as we go? Take a moment to think about this. When you lie under the night sky and feel the stars above you, the question of endings is not abstract. It becomes personal. You wonder not only about galaxies, but about yourself, your family, your place in this vast and fragile story. The universe becomes a canvas for human meaning, and the fates we imagine for it are brushstrokes painted from our own experiences. In this sense, science and myth are not enemies. They are companions, two ways of gazing into the mirror of the cosmos. Science gives us equations, models, predictions. Myth gives us symbols, metaphors, emotions. Together, they weave a tapestry in which the universe's end is both a physical process and a human story. And perhaps this is the true gift of the question, that it brings us closer to ourselves. The fate of the universe is so distant in time that no human will ever see it. The heat death, the crunch, the rip, the eternal drift, all lie trillions of years beyond our reach. Yet by imagining them, by telling their stories, we learn something about our own lives here and now. We learn to treasure the fragile warmth of stars, because one day they will fade. We learn to hold each other close, because one day distance may stretch everything apart. We learn to accept collapse, because in collapse there is renewal. The universe is vast, silent, indifferent. But when we ask how it will end, it becomes something more, a mirror that reflects the meaning we pour into it. The stories of the cosmos are, in the end, stories about us. And so, after traveling through science, through philosophy, through imagination, we arrive at a quiet threshold. The question is no longer simply which ending awaits the universe. It becomes gentler, more intimate. How should the story close? Not all endings arrive with answers. Some come quietly, slipping into silence, leaving more questions than certainties behind. The universe, for all its vastness and its mysteries, may be one such story. Science gives us many possible endings: collapse, fading, unraveling, isolation. Yet none of them are final in the deepest sense, because each rests upon assumptions that may shift. Each is framed by laws of physics that may one day be rewritten. The truth of the universe's end may remain forever beyond our reach, shimmering like a horizon that recedes no matter how far we travel. There is something haunting in that uncertainty, but also something gentle. If we cannot know how the story closes, perhaps we do not need to. Perhaps the meaning lies not in the final page, but in the act of reading, in the journey through the chapters, in the way the story lives through us. The cosmos is immense, and our lives within it are brief. Yet, in those brief moments, we experience wonder, love, beauty, and mystery. That, too, is part of the universe's story. Science can describe endings with precision, drawing timelines that stretch across trillions of years. It can measure the fading of stars, the slow drift of galaxies, the evaporation of black holes. But beyond these calculations lies a truth that is quieter, more elusive. The universe is not only matter and energy, it is also meaning and perception. To ask about its end is to encounter a mystery that cannot be solved by equations alone. It is to brush against the limits of human thought, to sense that some things are meant not to be answered, but to be contemplated. Perhaps the universe is like a lullaby. A lullaby is beautiful not because it is endless, but because it fades. Its beauty lies in its impermanence, in the way it begins softly, swells for a moment, and then drifts into silence. The notes linger in memory even after the song has gone, leaving behind a sense of calm, a trace of something greater. The universe may be the same. Its endings, whatever form they take, are not tragedies to be feared, but melodies to be heard in full, even as they dissolve into quiet. Take a moment now and imagine that fading. Stars wink out, one by one, like candles extinguished in a great cathedral of space. Galaxies slip below the horizon of visibility, their light stretched beyond perception. Even black holes, those giants of gravity, release their final sigh of radiation and vanish into nothing. What remains is silence. Not a silence of despair, but of completion. A silence that holds within it all the echoes of what came before. And in that silence, perhaps the universe does not vanish, but simply changes form, becoming something we cannot yet name. Perhaps the end is not an end, but a passage into stillness, a transformation into another kind of being. Just as the pause after a song is part of the music, so too might the universe's fading be part of a greater harmony. When we think of endings in this way, fear softens. We no longer imagine the universe as a doomed stage collapsing under our feet. We imagine it as a story told with care, a song that rises and falls, a dream that lingers even after waking. What matters then is not the silence at the end, but the richness of the song while it is sung. For us, that means this moment matters. This fragile instant where we breathe, where we wonder, where we look at the stars. Whether the cosmos collapses in fire or drifts into cold, the meaning of our lives does not vanish. It is written into the fabric of reality, like notes in a melody, eternal in their own way. The laughter of children, the light of the sun, the stories we tell, all of these are part of the song, resonating in the universe's memory, carried across time. And so as we stand at the edge of these questions, perhaps the wisest thing is not to seek a final answer, but to listen to the music of the stars, to the quiet pulse of time, to the faint echoes of creation still reverberating through the night sky. to listen and to rest, and to let the story be what it is: vast, mysterious, incomplete, and beautiful. Because in the end, the universe does not owe us clarity. It gives us wonder instead. It gives us the gift of not knowing, the invitation to dream, the space to imagine. It asks us to step into its mystery with humility and to accept that the most profound truths may never be resolved. Like a lullaby, the universe soothes not with answers, but with rhythm, with the gentle reassurance that we are part of something far greater than ourselves. Now let us step back. Let the voices of fire and silence grow faint. Let the questions we cannot answer drift into the background. Let the pace of thought slow until each word feels like a breath, each breath like a step towards stillness. The story has carried us across beginnings and endings, across galaxies and black holes, across science and philosophy. And now it softens, quiet as dusk, gentle as sleep. Every story has an ending. Yet this one fades like twilight slipping into night. The stars dim, the music stills, the universe drifts into silence, and we drift with it, carried on a tide that asks nothing of us but rest. And in that silence, there is peace.